before we go into further keys and the negotiation of the algorithm, let's take a look at what is actually the goal for all the derivation of the keys, and what kind of message confidentiality and integrity protection is actually provided in the 4G system. So we said that the mobile communicates with the MME using the non-access stratum. So this is the one of the main communications between the mobile and the network, where all the authentication negotiation happens, also where a lot of the mobility management happens, also for between the mobile and the network, and also the setup of all the session management. So this NAS signaling between the mobile and the network is encrypted, and not only is it encrypted, it is also integrity protected. That means the integrity protection here, as we kind of said in some of the previous part of this lecture, was that it makes sure that if any bit here has changed from a 0 to a 1 or from a 1 to a 0, then the receiving end knows that this is no longer a valid message. So it is not just encrypted but integrity protected. So someone in the middle over here, an adversary, just cannot change a bit from 0 to a 1 or a 1 to a 0 and still continue allow this to be a valid message. Or it also, the integrity protection makes sure that the adversary cannot just put in another message in the middle, basically a taped message from before, and just insert it into the middle so that the MME thinks that this is a valid message coming from the mobile. So both of this replay protection, as it's called, and also changing the bits or parts of the messages, both are being protected in the network. So the NAS messages are encrypted and integrity protected. Not only are the NAS messages encrypted and integrity protected, so are also the RRC messages. So the control plane messages between the mobile and the eNode B are integrity protected and are encrypted and integrity protected. There are two main signaling radio bearers that are being used. SRB1, as in the attached lectures we had covered, is used mainly for messages that are just RRC messages, direct messages between the mobile and the eNode B. SRB2, signaling radio bearer 2, is used for sending NAS messages or sending NAS messages between the eNode B and the UE. And these NAS messages are first encrypted by the mobile, by the MME, and then further encrypted again using the encryption and integrity protection keys of the mobile. So these are doubly encrypted as they're sent over the air. One of the things that you can see is, since the NAS messages are encrypted and integrity protected between the UE and the MME, the eNode B cannot look inside the NAS messages. So it doesn't know what NAS message the mobile is sending to the MME, or what the message the MME is sending to the eNode B. And this is an important property of the security which 4G system provides, because these eNode Bs are sitting out in the field on top of buildings or in remote places, and they can be hacked into. So these are not sitting in any centralized location. So these are sitting by the roadsides or on top of buildings in urban areas, which can be gotten to, also physically can be gotten to and hacked into easier than where the MME sits or the HSS sits, which is typically in data centers in more guarded and central locations. Of course, you can break in through through cybersecurity and things like that. I mean, through the internet, if you can get access to any of these data centers. But from a security perspective, at least from a physical security perspective, the eNode Bs are in remote locations, and And encrypting the NAS message provides protection against hacking into the eNode B. In addition to the signaling messages, what LTE or 4G security also provides is for the IP packets, or for the user plane packets of the user sent between the UE and the eNode B. These messages are encrypted, so but they are not integrity protection. So integrity protection is not provided to the user plane packets, with the assumption that there is end-to-end integrity protection. So typically the UE and the application that it is talking to, which is, let's say, YouTube or any other application that it is using, or just Google, there is end-to-end integrity protection, so that takes care of making sure that even if somebody puts in a wrong packet over here, the end node would go ahead and detect that this is not a valid packet from the mobile. So integrity protection is not provided, but encryption is provided. So you can be sure that if you are communicating, if you're doing a voice call with your spouse, then somebody else can't just go ahead and listen to what all you're saying, right? So that kind of security is provided. um, One of the things that I do want to cover, and cover what is essential, what is required and what is not required by standards. So in the NAS, integrity protection is a must. So integrity protection should be provided for the NAS messages. Encryption is optional. So encryption of NAS messages is optional, and it depends on what the operator wants to deploy. And typically, most operators do deploy encryption for the NAS messages. Also, for the RRC messages, it's the same thing. Integrity protection is a must, so it shall be deployed in the network, but encryption of the RRC messages is optional. And so the way the standard specifies these are that standard allows for different implementations to or different deployment scenarios to happen depending on the choice of the operators. Encryption of the user plane is optional also. So this is not a must, but this is something that an operator may choose to deploy. Most operators have deployed encryption for the user plane traffic also. As far as I know that there are some countries, and I won't name that, where encryption is not supported for the user plane traffic. All right, so from a standards perspective, this is what the recommendations, or this is what the standard says should be deployed. The reason to enable integrity protection for the signaling messages is that it's important that when the mobile does something, that a handover to another base station, or that it sees that, okay, the security algorithm is being agreed to, is that it better come from the network, or the UE knows that it's coming from the network and it's a valid message that only the network could have sent and not somebody else, based on the keys that have been agreed to.